Hi everybody, I'm Ed Thomas, President of Dimension 2000. What you're about to see is a sample slideshow from one of the lessons from our Algebra to the Core program. The slideshow provides prompts, problems, and challenges that can be displayed on a teacher's smartboard. The Algebra to the Core program provides slideshows for all the lessons. Let's check out the sample slideshow. So here, this one is about graphing the solution of a linear equation, and note this one says Method 2, the FAST method. So in our Algebra to the Core program, we teach kids two ways to graph a linear equation. One is more intuitive and requires more understanding. The other is the FAST method, which is where you plot the B point and use your slope to go over and up to get to the next point. But let's take a look at how the slideshow can help the teacher and the students. So first, the slideshow provides what we call a window of learning. And we actually post for the students what students will know at the end of this lesson, what students will understand, what students will actually be able to do, and what habits of mind students will develop as they progress through the lesson. And the window of learning appears on all of the slideshows, each slideshow associated with each topic. The second page of the slideshow provides a graphing grid that the teacher can actually print and provide for his or her students. So let's take a look at the hook. Here we have a Stouffer's lasagna box, and we have some sentences here with some words missing. So let's take a look. On the back of this box, you will find two sets of cooking blank. One set is for a blank oven, and the other is for a conventional blank. People who want to save blank are most likely to choose the blank instructions. So this is a nice way to introduce the FAST method of graphing a linear equation. Kids get to work with a partner and they read the sentence and see if they can figure out the missing words. And then the teacher has this on the slideshow so they can review with the students. So on the back of this box you'll find two sets of cooking instructions. One set is for a microwave oven, the other is for a conventional oven. People who want to save time are most likely to choose the microwave instruction. So connecting the hook to the math, just as lasagna meal box provides two sets of cooking instructions, one faster than the other, math provides two ways to sketch the graph of a linear equation, y equals mx plus b. One method is faster than the other. In an earlier lesson, students learned method 1, the slower method. This lesson focuses on method 2, the faster method. Now, we start by reviewing method 1, which was the slower method. So let's take a look. We have a phrase here that says sketch the graph of y equals 3x, take away 2. And the method we taught the kids with method 1 was first identify the question associated with the equation. See, every equation has a question associated with it. And the question here is, what is 2 less than 3 times the value of x? What is 2 less than 3 times the value of x? So step 2 was to choose 3 arbitrary values of x. And here in this example, I chose 0, 2, and 3. And step 3 was apply the question and plot points for each x. Notice the graph comes in. So applying it to the number 0, the question was, what is 2 less than 3 times 0? Well, 3 times 0 is 0, and 2 less than 0 is negative 2. So for the number 0, we plot a point at negative 2. Applying the question to the number 2, what is 2 less than 3 times 2? 3 times 2 is 6, 2 less than that is 4. So for the number 2 on the x-axis, we plot a point 4 units above the number 2. And applying to the number 3, what is 2 less than 3 times 3? 3 times 3 is 9, 2 less is 7. So above the number 3, we plot a point at 7. And notice these points are collinear. Step 4 says draw the line. And there you have the graph of the equation y equals 3x, take away 2. So that was method 1, the more intuitive method that involves understanding the concept that an equation is really asking a question about numbers on the x-axis. You get to choose the numbers, apply the question, record the answers, and plot your points and draw the line. Now, let's learn the faster method, method 2. Sketch the graph of y equals 3x, take away 2, and now we're going to go for speed. So what is this FAST method? The FAST method for sketching the graph of a linear equation includes 4 easy steps. And now we go into the proceduralization strategy where the teacher will model this new step-by-step process. Students will carefully watch and take notes on the step-by-step process. And then when the teacher's done demonstrating, the kids will work together. Student A will read their steps to student B while student B critiques. And then student B will read their steps back to A while A critiques. And then once they got their steps certified, then the teacher will provide 2 examples, a problem A for student A to work while B coaches, and then a problem B for B to work while A coaches. And so the proceduralization strategy is a great way to promote collaboration and communication. So let's take a look at the example that the teacher would actually model while the students take notes. Sketch the graph of y equals 3x, take away 2. All right, step 1, begin, and notice the red B. Begin by placing a point at B on the y-axis. So again, we bring in a graphing grid. And the B number in our equation is -2, so we place a point at -2. Step 2, write M, the coefficient of x, as a fraction v over h, vertical over horizontal. Think the number 3 is the coefficient of x, and we want to write it as a fraction. The easiest way to do that is 3 over 1. Step 3, place a second point at a location h, that's the horizontal units, and v, vertical units, from the point 0b. So since we're 3 over 1, we're going to go over 1 and up 3. And notice on the graphing grid that we have dotted lines to show that. And then we go ahead and place that point. And now step 4, draw the line that contains the 2 points. So this method is a little different than method 1. This is method 2, the FAST method. And so the teacher would model this. We have the PowerPoint or the slideshow to assist in class, and the kids would take their notes. And then remember, after the students take their notes, they would read their notes to each other and make sure they have the right notes. Now here's a second example. This one we have a fractional coefficient of x, but you'll see the steps work the same. So we begin by placing a point at B on the y-axis. So our equation is y equals 2/3 x plus 1. So we're going to place a point at the number 1 on the x-axis, on the y-axis. Step 2 was write the coefficient of x, m, as a fraction. Well, think 2/3 already is a fraction, so we're set to go. Step 3, place a second point at a location 8 units horizontally and v units vertically from the point 0b. Well, our point 0b is 0, 1, so moving 3 points horizontally and 2 points vertically will look like this. You can see the red dotted lines. Now we place our point, and then step 4 says draw the line that contains the 2 points, and we have our graph of y equals 2/3 x plus 1. So now that the kids have seen their 2 examples, now is when they would go ahead and read their steps to each other and verify they have the right steps. And then the teacher is going to provide a problem A for person A to solve. And here it is, y equals 4x minus 3. So while partner A is solving this problem, person B is watching what they're doing and providing prompts like, yes, I think you're doing this correctly, or whoa, wait a minute, I have a question about what you just did here. They're providing coaching to the student so the student can be successful. Remember, that's a key part of the program to help students be successful in algebra. So when problem A is done, then the teacher would address the class and say, okay, can I have a volunteer, someone who worked problem A, to lead us through the solution? And notice that again on the slideshow we have the solution. Begin by placing a point at B on the y-axis. Write m as a fraction. 4 equals 4 over 1. And then place a second point from that y-intercept by going 1 point horizontally and 4 points vertically. And then place your second point and draw your line. And so this is really good because the folks who were partner A worked this problem. B was watching carefully. Now you have an opportunity for person A to explain to the whole class how this was done. Everyone's watching. And now you turn around and provide a problem for person B. And so now B works the problem while partner A provides the coaching. And then after a few minutes, again, you ask for a volunteer of a partner B, and they would explain and go through the procedure again. So notice, again, the RVD model, a lot of repetition. The kids are getting a lot of practice right here in class. But the variation, first they're watching the teacher do it, they're taking notes, and now they're doing it themselves or providing coaching, and the variation is built right into the strategies. So we plot the point at -2. The slope is already a fraction 3/4, so we're going to move 4 units horizontally and 3 units vertically. And we're going to place a second point, and we're going to draw our line. And again, the kids are being successful because of the way we're presenting this and the fact that we're allowing them to collaborate and communicate with each other and play the role as problem solver and that of a coach, taking turns working together. And this is how we build the success into the algebra program. Now, notice built right into the slideshow is the next strategy, graduated difficulty. Now, with this strategy, what we do is we provide the class with 3 different problems to solve. Knowing that level 1 problem is the easiest of the 3, level 3 problem is the most challenging of the 3, and the level 2 problem is somewhere in between. Now, what's nice about this strategy is we let the students choose which one they would like to solve. So this is differentiation by levels of difficulty. Let's take a look at the 3 problems. So level 1, sketch the graph of y equals 2x plus 4. Level 2, sketch the graph of 1/3 x take away 5. And level 3, sketch the graph of y equals 0.25x plus 2.5. So you can see why one is more difficult than the other or more challenging. The level 2 has a fractional coefficient of x. Level 3 has a decimal coefficient of x and a decimal for the b number. And in level 2, the b number is a -5, a -5, and level 1 is just +4. So the kids like this because they get to choose. And it's okay for some kids to choose level 1 if they feel like that's the highest level they can be successful right now. But think about your kids who are really sharp and they're catching on fast. They have an opportunity to work the more challenging problem. Everybody's working at the same time. The teacher's facilitating the class, but you're actually differentiating by level of difficulty. Now, what would follow on the slideshow, and I'm going to escape out of here real quick so you can see, but what follows from here are the 3 solutions. So here's the level 1 solution. Again, you would go through this with your students. Here's the level 2 solution. You would ask who chose level 2, and let's talk through the solution. And who chose level 3, let's talk through the solution. And again, more repetition, more variation, and we're definitely going into depth because as the students have a chance to explain their work, you can ask key questions and really help the students to better understand the content. Next in the slideshow is Convergence Mastery Challenge. And in this challenge, what we do is we provide 3 quizzes for the kids. Now, it's not the kind of quiz where you actually get a numerical grade. We actually assign 2 letter grades. One is E for excellence, and the other is N for not there yet. And to earn the E for excellence, you have to solve these problems without error. No errors at all. Otherwise, you get a not there yet. But see, what we do is we provide 3 quizzes for the kids. Now, what you're seeing here are the quiz and the solution, but when you run the slideshow, and I'll just show you real quick, when you play the slideshow, the kids just see the quiz questions themselves. So they're asked to sketch the graph of these 2 equations. And you only give them about maybe 6 minutes, say, to solve these. And then you say, okay, guys, let's go ahead and check our work. And you can do this with kids exchanging papers. It's not something the teacher wants to take home. That's not the idea here. But see, now with the slideshow, you bring up the solution to problem 1. It shows the slope is as a fraction is 2/1. The y-intercept is 3. So you plot 3, and 2/1 is over 1 and up 2. Plot your second point and draw your line. And then the second graph comes in, and we address question 2. The slope is 2/5. The y-intercept is 1. So we plot at 1, and we go over 5 and up 2. And we place our second point. And so the kids get to see, did they do it right or did they do it wrong? And after the first 6 minutes, after the 6-minute quiz, and you evaluate the kids' work, Then you have a time where you actually help the kids to see what they did wrong, because quiz 2 is coming up next. And so the kids who did not get the E for excellence, the ones who got the not there yet, they will take quiz number 2. Now the kids who got the E for excellence, they now become the coaches in class, and they're helping the kids to see what they did wrong on the first quiz. And then of course you'll show the second quiz. I'm going to break back out of the program and show here's quiz 2. So now the kids who did not get the excellence would then do quiz 2. After they've had a chance to learn from their mistakes and see what they did wrong, they'll come back and take quiz 2 during the same class period. And you go through the same procedure. So about 5 or 6 minutes to take the quiz, and then you evaluate kids' work. The ones who do it without error, they get their E for excellence, and they become coaches and help the kids who are still not there yet. And then notice we have a third quiz as well. So this is the procedure for doing convergence mastery. That's the strategy, and it's a really great way to help kids become masterful at a math skill. All right, let's move forward. Now we have a pick one, get one vocabulary challenge built into the slideshow. And what we do on this is notice the slideshow shows key vocabulary words and phrases associated with the lesson. And what the teacher's going to do is the teacher's going to ask a student to stand, and the student gets to pick one of the words or phrases on the list. And upon choosing one, the teacher's going to explain to the student and to the class how that word or phrase connected with the lesson that the kids are working on. Now, after the teacher does that, the teacher then gets to pick one of the words or phrases, and the student who is standing has to explain to the teacher how that applied to the lesson, so its meaning and what its role was in the lesson. And then when the student has done that successfully, that student sits down, the teacher picks another student, and then another student would stand and choose one of the words or phrases. The teacher would explain, and then the teacher picks a word or phrase and the students explain. And after we do that with about 5 kids, then we let the paired learners work together, and they get to do that with each other. Partner A would choose a word or phrase for partner B to explain, and partner B would choose a word or phrase for partner A to explain. And it's a great learning environment where the kids are really zeroing in on the meaning and the role of the words and definitions, and it's a really nice vocabulary challenge. Okay, moving forward, then we have a proof of understanding challenge. Now, the proof of understanding has to do with the fact that there are certain understandings we want kids to walk away with from the lesson. So let's see what we have here. So here's 3 questions that demonstrate that if the kids can answer this very well, would demonstrate their understanding. So number 1, why is an equation of the form y equals mx plus b called a linear equation? And we would allow kids, they could work with a partner. You could do this with stand and deliver, where the students stand and talk back to the teacher. But it's very important that students understand why this is a linear equation. Question 2, why does plotting B on the y-axis always provide a point on the line? Question 3, explain the relationship between M, the slope of the line, and what we call the rate of change. So these are 3 understandings I would want students to come away with from our lesson on graphing linear equations. So the nice thing about the slideshow is you can use this on your smartboard or with your projector in class, and it makes for a very nice guide as you work with the students, and the prompts for the strategies are built right into the slideshow. And think about it now, you get to you get these slideshows for each of the lessons that go with the Algebra to the Core program. Now, I can tell you from experience, I've done these lessons with these slideshows with a lot of students in a lot of classrooms, and it's amazing, and the teachers of the classes in which I've demonstrated, they're amazed as well, is how powerful the collaboration, the communication, the challenges, how amazingly this helps students to really learn their algebra much deeper and with higher levels of success. This really does work. And so this is what Algebra to the Core is. It's a step-by-step, strategy-by-strategy approach to teaching kids algebra, and it's also the support provided by the slideshow, which is what makes this a great program.